The sin 3 into t minus pi आया है here. Sin 3 into t minus pi, right? So you can write it in the term of what? ये किसके टर्म पे आएगा? अल्टीमेटली वो एंगल सब एंगल वाला फॉर्मूला लगाएंगे तो ये साइन ही आ जाएगा. sin 3t, it is either plus sign or minus sign. It will be plus or minus sin 3t, that is depending on the quadrant. So you can check in which quadrant it is lying. Okay, that is your task. Do you get it what I am telling?
Yes, sir.
Yes, sir.
Sin 3 into t minus pi, that you can write as sin 3t or minus sin 3t, that is depending on the quadrant. I am not verifying the quadrant, you just verify it and you write whether it is plus or minus. Actually 3 ना तो 6 हो जाएगा. 6 मतलब 1 2 3 4 5 6 and that 6 minus of something मतलब 1 2 3 4 5 6 6 minus, ये फर्स्ट क्वाड्रेंट पे ही आ रहा है ना. Okay, you do it. I can try. It will take some time. Okay. So in that problem, we are not using the first shifting theorem. There is no use of it. But in the problem number 12, the last class which we have solved, that uses both, right? First and second. Problem number 12. Similarly, you can try 14, 15, 16. These are simple. There are no use of second shifting, sorry, first shifting. Only by using second shifting, you can solve problem number 14, problem number 15, problem number 16. But for problem number 17, we have to use both shifting property, because you can see it is a function of s plus 1. So I am showing a bit, you check it. 17. Laplace inverse of 1 plus e to the power minus 2 pi s plus 1 divided by what? Into s plus 1 into s plus 1 divided by s plus 1 whole square plus 1. This, right? Okay. Now see, in this problem, we can use any of the shifting theorem first. तो कोई भी shifting theorem को पहले use कर सकते हैं. That is depending on you. कौन सा apply करना चाहते हो? Tell me which shifting property I will use. Better to use, I think, first shifting theorem. Okay. So to use first shifting theorem, the given function should be considered as function of s minus a. So here it is function of s plus 1, right?
Yes.
So f of s plus 1, I'm going to apply first shifting. That is why I'm writing in that way. 1 plus e to the power minus 2 pi into s plus 1 whole bracket s plus 1 divided by s plus 1 whole square plus 1. Okay, it is completely a function of s plus 1, and according to the formula, first shifting formula, Laplace inverse of f of s minus a, it is what? E to the power at into ft. So ft means Laplace inverse of fs. So from f of s plus 1, I have to write f s. So what is f s? You replace s plus 1 by s. 1 plus e to the power minus 2 pi s whole into s divided by what? A square plus 1. So you getting?
Yes, sir.
And what is small a? Minus 1. देखो ये जो कंपेयर कर रहा हूं, आई एम कंपेयरिंग दिस विद द फर्स्ट शिफ्टिंग. तो अल्टीमेटली आंसर जो है वो लिखूंगा क्या? e टू द पावर 80 इंटू एफ टी. तो आई एम कंपेयरिंग इट विथ फर्स्ट शिफ्टिंग थ्योरम. So you can write the first shifting Laplace inverse of f of s minus a is equal to e to the power at ft. Okay, so I got a which is minus 1. Now I need ft, right? I need ft. So how to get ft? Simple, Laplace inverse of fs. Now ft, it is Laplace inverse of fs. That means Laplace inverse of 1 plus e to the power minus 2 pi s whole bracket s divided by a square plus 1, right? Now to find that Laplace inverse, what you will do? It contains e to the power minus as type of term. So you can rearrange it, you can rewrite it in the form of e to the power minus as into fs. So you have to firstly split it in two fractions, Laplace inverse of s divided by a square plus 1, and the second part Laplace inverse of uh, e to the power minus 2 pi s into s divided by a square plus 1. Any doubt? Tell me.
No, sir.
Hey, I have multiplied s. In the previous line, I have multiplied both term by s and then separated. Right? And for the first term, Laplace inverse is simple. Right? From the table, you will get what is the Laplace inverse of s by a square plus 1?
Cos t.
Cos t. Correct. And for the second part, what we will do? For the second part, it is of the form e to the power minus as into fs. So t shifting. So you compare with the t shifting property and tell me what will be the uh, answer for the second part. देखो, what is a? According to the t shifting, what is a? E to the power minus as into fs. What is a? देखो ये फॉर्मूला देखो, e to the Laplace inverse of e to the power minus as into fs. Compare with this problem. So e to the power minus as into fs. What is a?
Minus 2.
My, huh? E to the power minus as. The form is e to the power minus as into fs. So a is 2 pi, right?
2 pi.
Yes.
A is 2 pi and fs is s divided by a square plus 1. So we got a and we got fs. So from fs we will get ft. What is ft? देखो already ft निकाला हुआ है. F मतलब s by a square plus 1, that is fs. And what is the Laplace inverse of it? That is ft, na? So it is cos t. So ft will be cos t. Then ft minus a, that means what? Ft minus 2 pi. What it will be? Tell me. Cos t minus 2 pi, that is f of t minus 2 pi, na? And ut minus a भी रहेगा, this. Any doubt? देखो अगर डाउट है तो पूछ लो अभी से, नहीं तो डाउट रह जाएगा, देन बाद में दिक्कत होगा. First you think that which formula is applicable, then you write the formula, then you compare. Okay, compare with the formula which I need, which informations are given and which I need. Okay, tell me, any doubt?
No, sir.
So ft we got, is it the answer? That ft we have written, is it the answer? Is it the Laplace inverse of the given? Look, firstly we have applied the first shifting, means s shifting, right? So Laplace
Yes,
inverse
sir.
of f of s minus a is equal to e to the power at into ft. And to find that ft, we are doing this. ये ft निकालने के लिए ये सब किया, जो भी किया है. That ft we have calculated. So lastly you have to write the answer, na, because the answer is of the form e to the power at into ft. Now what is a? A here -1. देखो यहाँ पे दो तरीका का a है. Whenever you are applying the first shifting, in that case a is -1, and for this part, whenever you are applying the second shifting theorem, a is your 2 pi. So two different type of a, टू डिफरेंट केस में वो मिक्स मत कर देना. ओके,
Yes, sir.
so ultimately the Laplace inverse of the given function equals to e to the power at, that means e to the power minus t into ft. Ft means that cos of t minus 2 pi means what? ये फोर्थ क्वाड्रेंट ना, 2 pi minus t minus sorry, in the fourth quadrant cos is plus, so it will be cos, na? Am I correct or something wrong? Cos t minus 2 pi क्या होगा? Cos t minus 2 pi. You should answer this.
Cos t.
It is cos of 2 pi minus t, because you know that sorry, you know that cos of minus theta is equal to cos theta. So I can write this. Now it is cos of 4 into pi by 2 minus t. Now it is in which quadrant, that angle? 4 into pi by 2 minus t. It is in the fourth quadrant, right? So it will be cos t. In the fourth quadrant, cos is plus, so it is cos t. And because of that even multiple, cos remain cos. Do you think any mistake I have done, or It is okay. देखो यहाँ पे मैं गलती कर सकता हूँ because I forgot many of the things that in +2 level things, trigonometries and so on. But I think it is correct. जो भी मैंने दिखाया. You check it once, and if you think it is wrong, you can explain. क्या सही किया है कि नहीं बोलो. या तुम लोग भी भूल गए हो. No one is replying.
Yes, sir.
Okay. Now our main focus, which is to solve initial value problems. Okay. So what is the difference with the previous chapter? In the previous chapter also we have solved some initial value problems. Here the difference is the function in the right hand side. You know that whenever an ODE is non-homogeneous, there are some non-zero function in the right hand side, RT or RX, whatever you call. Are you getting? So that Rx or RT here, that can be a Heaviside function, or that includes Heaviside function. Okay, ये डिफरेंस है. मतलब Rx चेंज हो गया. यहाँ पे Rx जो है 18 to 27 में Rx जो है वो Rx contains Heaviside function, क्योंकि in this chapter I have introduced Heaviside function, right? So Rx may contain Heaviside function. That is a difference with the previous chapter. Now देखो for problem number 19 there are no use of the Heaviside function because Rx is 0. So it is there are no difference with the previous chapter problem. Okay, it is similar to 6.2, and 19 also there are no bound on the Rx, so it is not related to Heaviside function. So it is also related to the previous chapter. You can solve it. 20 also, I don't know why they have given these problems here, because in the previous chapter we have solved this type of problems. Okay, maybe the reason is whenever you solve ys, that ys contain e to the power minus a term. Maybe that is the reason. You can try. I'm showing this. Okay, problem number 21 or 22. So what is the problem you see? 21, it is y double dash plus 9y is equal to 8 sine t. Okay, if t lies in between 0 to pi, and 0 if t greater than pi. So I'm firstly explaining the problem. Is problem number what? 21. And what kind of mistake students did with this type of problem, that I will also tell. Y double dash plus 9y is equal to 8 sine t. 8 sine t whenever t lying in between 0 to pi, or it may be open interval, not an issue. and 0 whenever t greater than pi. So here the right hand side means RT. Usually we denote that right hand side of a differential equation, it is RT or Rx, right? Here the independent variable is t, so right hand side is RT. So here RT is this. It is not a single function, it is a piecewise function. Do you get it?
Yes, sir.
The students actually often do not understand this. ये right hand side क्या दिया है, वो लोग क्या करते हैं मैं बता देता हूँ, मतलब क्या किए हैं तुम्हारे सीनियर्स. They have solved y double dash plus 9y is equal to 8 sin t. They have solved this as well as they have solved this. Means they have solved these two differential equation. Okay. So it is not correct. Fine. So what you have to do, you see, if the right hand side function it is defined in a finite interval or it is piecewise, in that case it should be expressed in terms of Heaviside function. You can express it, right? I'm writing ART, which is 8 sine t in the interval 0 to pi and 0 whenever t greater than pi. So in a single line, what I can write? In terms of Heaviside function, 8 sine t, it is defined only in the interval 0 to pi. So you can express it in Heaviside function. Na? What is the technique? I told.
8 sin t ut minus pi.
ut minus pi, right? And there are second piece also, and but the value of the second piece is 0. So 0 into whatever you write, actually it is 0 into t minus ut minus pi, right? The second part. So it is not needed because the second piece it is 0. Whatever you multiply it with it will be 0. So no need to write it. If the otherwise case is 0, then ignore it. Only we have this. So our differential equation is now y double dash plus 9y is equal to 8 sine t, ut means 1 minus ut minus pi. Okay, it is our differential equation. Now you solve it by taking Laplace transform. You take Laplace transform both sides, then you apply the derivative formula, and in the right hand side, to find the Laplace transform, you have to use de-shifting property, right? Look, I'm writing a few lines. Then you continue. I will not complete it. Means I left in the middle. So taking Laplace transform both side. Some initial conditions are there, no? I have missed it, I think. There should have some initial conditions, otherwise we cannot solve it by Laplace transform. Yes. y0 0, y dash 0 4. This. So I am taking Laplace transform over the ODE. So Laplace transform of y double dash plus 9 Laplace transform of y is equal to Laplace transform of, look, it has two parts, 8 sine t minus 8 sine t into ut minus pi. 8 sine t minus Laplace transform of 8 sine t ut minus pi. Okay, and then you apply the formula for derivatives. So a square, it is ys. A square ys is what? Usual notation. Ys means Laplace transform of y minus small y0. These are small. Sy0, sorry. Sy0, y dash 0. plus 9 into ys. What is the Laplace transform of 8 sine t? This. Now what is the Laplace transform of next part? Can you tell me? It is of the form what? Ft into ut minus a, right? Ft into ut minus a. So you have to apply modification of t shifting. So what it will be? Here a is confirmed. What is a? It is pi. So minus e to the power minus pi is Laplace transform of what? F of t plus a. So if t is 8 sine t, it will be 8 sine t plus pi. Do you get it?
Yes, sir.
It is f of t plus a. If t is 8 sine t. So f of t plus a, that means f of t plus pi. अगर समझ में नहीं आ रहा तो राफ में लिख लो, लिख लिख के करो, बेटर होगा. एफ टी क्या है, देन एफ ऑफ टी प्लस ए क्या है, वो लिखने से सब पता चल रहा है. So e to the power minus pi is Laplace transform of 8 sine t plus pi. Okay. Now we know the values of y0 and y dash 0. So y0 it is 0 and y dash 0 4. So a square y is it is 0 and minus 4 plus 9 y is 8 divided by a square plus 1 minus e to the power minus pi s. And you tell me what is the Laplace transform this sine t plus pi. That means it is which quadrant? Actually third quadrant. No? Minus. It is minus sine t, right? So minus 8 into 1 by a square plus 1. Minus sine t का Laplace transform. Minus 8 sine t. Do you get it?
सर माइनस वाला समझ, -8 कैसे लैप्लास में?
Look, 8 is common. You can take it outside the Laplace transform. So it is 8 into Laplace transform of sine t plus pi. And sine t plus pi means minus sine t. Do you agree?
यस सर, यस सर.
So it is basically what? 8 into अब वो माइनस जो है वो बाहर आ जाएगा. So minus 8 into Laplace transform of sine t. क्या हो जाएगा? Minus 8 into 1 by a square plus 1.
1/s² plus 1.
Fine. Now you simplify it. A square plus 9 into ys is equal to 8 divided by a square plus 1 minus 8 e to the power minus pi s divided by a square plus 1, and this 4 plus 4. Okay. Therefore ys a square plus 1 into a square plus 9 plus 8 e to the power minus pi s a square plus 1 into a square plus 9 plus 4 divide. Okay, it is minus now. 4 by a square plus 9. Now you find its Laplace inverse. Y t is equal to what? Laplace inverse of ys. So you find the Laplace inverse of this. Is it easy? There are 3 terms. Okay, so you have to find the Laplace inverse of these 3 part. So part wise you find the Laplace inverse. First part Laplace inverse, second part Laplace inverse, third part. Third part ka Laplace inverse, it is easier. It is directly coming from the table. And first part, for the first part you can apply the partial fraction, and for the second part you have to apply t shifting. Okay, so you do it. It is your hostel work. No, you are online students, so it is your homework. Okay, now I am coming to the next problem. I'm showing one more problem. Just the next problem you see 22 y double dash plus 3y dash plus 2y y double dash 3y dash plus 2y 3y dash plus 2y is equal to 40 is equal to 40 whenever t lying between 0 to 1 t lying between 0 to 1 and 8 whenever t greater than 1. Okay, so we can write it in that way also. This y00 y dash 00. Fine. Now RT here you express RT in terms of Heaviside function because the function is piecewise function. So RT is what? 40 into, tell me.
1 minus ut minus 1.
1 minus, that means ut minus, actually it is ut minus 1 and ut you can write 1. So 1 minus ut minus 1 plus 8 into u t minus 1, right?
Yes, sir.
You can simplify it. So 40 and 1 and 8 into ut minus 1. You can write 40 minus 40 plus 8. Minus 40 plus 8 into u t minus 1. Okay. Therefore, our ODE is y double dash plus 3y dash plus 2y is equal to 40 plus minus 40 plus 8, or you can take minus common. If you take minus common, then it will be what? 40 minus 8 u t minus 1. Then as usual you take Laplace transform. So Laplace transform of y double dash plus 3 into Laplace transform of y dash plus 2 into Laplace transform of y is equal to Laplace transform of 40 minus Laplace transform of 40 minus 8 into u t minus 1. Now I am applying the derivative formula. So a square y(s) minus s y0 minus y dash 0 plus 3 into s y(s) minus 3 y0 plus 2 into y(s). What is the right hand side? 40 means 4 divided by a square, right? And the second part, it is what? Laplace transform of ft into ut minus a form. So you apply the modification of t shifting. Bolo. So you can write it actually what is ft in the rough In the rough, you can write what is ft. Ft will be 40 minus 8. Then what is a? 1. So the formula is what? Modification formula is Laplace transform of ft ut minus a is equal to e to the power minus as into Laplace transform of f of t plus a. Right? So f of t plus a I need, and here a means what? 1. So f of t plus 1, what it will be? 40. 4 into t plus 1 minus 8. So that will be 40 plus 4 minus 8. So 40 minus 4. So ultimately I can write second part. It is minus e to the power minus s Laplace transform of 40 minus 4. Are you getting how I have written 40 minus 4? E to the power minus as into Laplace transform of f of t plus a. That is the formula. If you do not remember the formula, then the overall things, it looks absurd. Do you get it? Or any doubt? Tell me. From this line to this line, is it clear to you?
Yes, sir.
Or do I need to write the formula? Others?
Yes, sir, clear.
Yes, sir.
Okay. Now you put the values y0 and y dash 0. Both are 0. So it is the simplest case. You put it, only a square ys term is there, and plus 3 into sys and 2ys, this much, equals to 4 by a square minus e to the power minus s into Laplace transform of this. What it will be? 4 by a square minus 4 by s. Okay. Ultimately, ys, it is a square plus 3s plus 2 ys, it is 4 by a square minus e to the power minus s into 4 by a square plus e to the power minus s into, I'm separating it into two parts, into 4 by s. 4 by s. Therefore, ys. What is ys? 4 divided by a square. Can it be factored? A square plus 3a plus 2, 3s plus 2? Yes. 2 and 1. Na? S plus 1 into s plus 2. Minus e to the power minus s into 4 divided by a square s plus 1 s plus 2 plus e to the power minus s into 4 by s into s plus 1 into s plus 2. So there are three parts, right? There are three parts. So yt means we have to find Laplace inverse of ys. Okay. Look, be careful about the notation. This capital Y and small y I am using. Whenever we are applying the derivative formula, first term it is capital Ys. Okay. Others are small. So be careful. Here also, first it is capital Y and others are small. You see the go through the formula, you will get it why I have written that. So Laplace inverse of 3-part, right? In the previous problem also we got Laplace inverse of 3-part. Here also we are getting Laplace inverse of 3-part. So is it a difficult one? Because finding Laplace inverse of 3 means it is equivalent to 3 Laplace inverse problem. What I will do? Actually, all these 3 parts are related. Okay, means in a single sequence, you can find the Laplace inverse of each. All these 3 are related. Na? Dekho, first term it contains 4 by a square plus a square into s plus 1 into s plus 2. Second term में just it is multiplied with e to the power minus s. Third term में e to the power minus s into 4 divided by s into s plus 1 into s plus 2. So it is actually it is a chain, it is a sequence. By means you have to manipulate it that how can I means find the Laplace inverse so that in a single way I can find the Laplace inverse of all these 3. You tell me. In which way I will find this? Can you tell me? Anyone? You try it. I am giving you as a homework for this also. So I am telling you the way. Okay. So first of all, you find the Laplace inverse of this. 4 divided by s into s plus 1 into s plus 2. You find the Laplace inverse of this. And that can be done by the formula fs by s, right? It is something of the form fs by s na. You can do it by partial fraction also. Partial fraction में भी कर सकते हो, but fs by s से भी चलेगा. So first you find this Laplace inverse of this, okay, and in the second step you find Laplace inverse of this. मतलब नीचे स्क्वायर होगा क्योंकि ये दोनों रिलेटेड है ना. नीचे s से अगर कर लिए तो s स्क्वायर के लिए और एक बार इंटीग्रेशन करने से हो जाएगा. दैट आई टोल्ड ना. fs by s square form ये सब मैं बताया था.
Yes, sir.
So first you find Laplace inverse of 4 by s into s plus 1 into s plus 2. Then you find Laplace inverse of 4 by a square into s plus 1 into s plus 2. Then you find this 2 overall e to the power minus s into fs form this. मतलब यहाँ पे ये वो वाला यूज हो जाएगा जो तो हम लोग निकालेंगे वो दोनों यूज करके एंड टी शिफ्टिंग यूज करके सेकेंड एंड थर्ड का भी निकल जाएगा. So you try. And next class I will complete otherwise. Okay, thank you all. I'll give all.
Thank you, sir.
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 Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.